welcome back. This is live session 4, What Did You Miss? Part 2. So the first part was factoring. So if you want to see the factoring, go back to part 1. This part is specifically going to go over the middle part of the lesson, which was talking about degree, zeros, maximum, minimum, and in behavior. So the first thing we need here is a definition of degree. So from now on, we're going to be talking about things that only have one variable on them. And that's because we're talking about a function, so the variable is most likely going to be x. So when you're talking about that, the degree of the polynomial is simply the highest exponent on the variable. So while I talk about this, I'm going to be using an example you guys are really familiar with, which is a quadratic. And so as we look at this, you're going to see that the highest exponent, there's multiple exponents. Here there's 0, here it's 1, here it's 2. So for this, the degree would be 2. Okay, so that one's pretty simple. Moving on, we have the maximum number of zeros. So there's a really cool relationship here, which is simply the max number of zeros is equal to the degree. And once again, we can use that idea of a quadratic to see that. You can see this quadratic has 2 x-intercepts. And this is a really common way that we'll see quadratics, whether they're going up or down, they typically cross that x-axis twice. But the reason why we say it's the maximum number is because I know it's not possible for this one to come back. It's not going to cross again. However, it could cross less. Sometimes you see ones that look like this, where they're just kind of sitting on the x-axis. So they only have one x-intercept. Or sometimes we see ones that look like this. Let me draw that a little bit more obvious, where it doesn't touch the x-intercept at all. So this one has 2, 1, or 0. But because the degree was 2, that maximum number is 2. Okay, so then the next thing is talking about the maximum number of turning points. Reminder, when I'm talking about turning points, I'm talking about those local max and mins. And so those are those hilltops and those valleys. The relationship here is really similar, but it is different. It's not exactly equal. It's one less. So your degree minus 1 is equal to your turning points. Some people like to write that differently, and so your turning points plus 1 is equal to your degree. Once again, this is the maximum. Typically, this is correct, but just like we saw over here where it could be less, you could see the same thing here. You could have less turning points than what the rule says you can have. However, you can never have more. And we see this by saying, okay, this has 1, 1, and 1. The degree was 2 minus 1 equals 1. So they each have 1 turning point. So let's put this into practice of looking at how can we find this information from a equation. So to find it from the equation, the first thing we're going to notice is the degree. So once again, the degree is that highest exponent. So we have 0, 2, 4, 5. So my degree is 5. It's that highest exponent. So once again, we have 0, 3, 6. So my degree is 6. Because of that, I know that the maximum number of zeros is exactly that same number. And then I know the maximum amount of turning points is 1 less. And when you have an equation, it's as simple as that. Find the degree. You know that's your maximum number of zeros. You know that that's the degree minus 1 is your maximum number of turning points. So the next slide says, how can we put this together? So what I would like you to do is, if you're watching this on your own time for the very first time, is try and answer the slide on your own first. I'm going to go ahead and keep going. So So what I did here was I first found my relative minimums, and so we knew we were looking for those valleys. I then found my relative maximums. I was looking for those peaks. I did not take these edges here because those are not hilltops, they're not a peak. They don't count. I don't care right now about the ends. That's something different. I wanted just these peaks. So there's 2. Our relationship said that the turning point plus 1 is typically our degree. So I had 5 total turning points, so that means the degree is most likely 6. We could also do this by looking at the zeros. We want this relationship to match. So I can say there's 1, 2, 3, 4, 5, 6 zeros. And the last slide just said that your number of zeros is equal to your degree. So this is also saying that my degree should be 6. So we can see that there is a match here. Okay, so that's how you can see from the graph and how these things are related to each other. The next 2 or 3 slides is actually 4, I think. It's still going to be talking about degree, but also its leading coefficient and how this stuff is related to end behavior. So on the next few slides, we are going to be talking about the ends. So if you're copying this down in your notes for the very first time, you'll see what I ask you guys to do here is to copy it down and make sure that you are leaving room beneath them to sketch a graph. You're going to see this graph in the next 2 pages, just so you can have a picture for it. Once you do that, you're asked to find the leading coefficient and the degree. So if you're taking the notes for the very first time, go ahead and pause and do that. So the first thing I'm going to do is I'm going to find the degree of each of these. So the degree, once again, is that highest exponent. So here, my highest exponent is 4, 2, 3, and then here, it's not actually shown. And so that's a really good reminder that if it's not actually shown, it's a 1. So here I have a degree of 4. Here I have a degree of 2, a degree of 3, and a degree of 1. So this is a good reminder about finding your leading coefficient. Your leading coefficient is attached to the same term that gave you your degree. Your leading coefficient is attached to the same term that gave you your degree. So I'm going to look right here in front of each of these. So very similar to the one right beneath it. There isn't actually in that spot that I highlighted, and if there's not something in that spot where you know you're finding your degree or your leading coefficient, then it's just a 1. Make a really big deal here, however, that this is a positive 1, and we'll see why in the next page. On this one, my leading coefficient is -2. I have another leading coefficient of -2, and this one a leading coefficient of +3. So you will see these in the next few slides. We needed to find the degree and the leading coefficient first because we're going to see how those relate to our end behavior in the next few slides. So this is going to be important once again where you're trying to come up with this relationship on your own first, and then you're seeing what I write. It's going to be more important if you try and come up with a relationship on your own first so that you can really understand what I'm about to tell you. So the relationship that you're coming up with, we have 2 of the 4 we just looked at, and I'm asking you to find what do these graphs, really important, their end behavior. What do the end behavior have in common? And what in general do these graphs have in common? No, back up. What do the end behaviors have in common? And then how is that related to their degree and their leading coefficient? So very specifically looking at the degree and the leading coefficient, and we're looking at the end behavior. So once again, if you're doing this for the first time, you need to pause and try and come up with that on your own as you sketch these out. I'm going to keep going. So as I just drew the arrows in, you may be able to see that the first thing that you should notice that they have in common is that their ends are together. And what I mean by that is they go in the same direction. So these two went up, these two went down, but the ends went the same for each of them. The reason why comes with something else they have in common, which comes from their degree. We have 4 and 2, and those are both even numbers. Now, some people came up with some different things they have in common, but those are the important ones. So this is what you need to make sure that you're understanding. The ends go together because the degree is even. Now, there's some differences here. On this one, they're going up. Over here, they're going down. Once again, obviously, I'm talking about the end behavior of that. And so we find that because of their leading coefficient. And I made a big deal about that. On this one, the leading coefficient was positive, so the ends are going up. On this one, my leading coefficient was negative, so my ends were going down. So the big takeaway from the screen is that if it's an even, so once again, when we talk about even, we're talking about that degree, your ends are going to go together. If it's positive and even, both ends go up. If it's positive and odd, both ends go down. Nope. I'm going to say that again because I have it written right, but I said it incorrectly. If it is even and odd, both ends, no. If it's even and negative, I'll write it out there, even and negative, both ends go down. I'm so sorry that I said that incorrectly twice. Go with what I have written. All right, so here you're going to be asked to do exactly the same thing, but these are two different graphs. So how are their ends common? How are their ends different? And what do you notice about their leading coefficient and their degree? Once again, take a moment to pause. Go ahead and sketch these out and everything after you do that, and then come back to hear my explanation. Okay, so hopefully you're noticing that we're going to use the relationships we saw on the last slide. Common here is that the ends are opposite. What I mean by that is each of them has one end that goes up and one end that goes down. If we go back and look at that relationship of degree again, that is because the degree is odd. So degrees that are odd are going to have opposite sides. I like to come up with little things like that, but odd and opposite. So an odd one means that I have one end that goes up and one end that goes down. The difference here then has to do with the positive and the negative again. This one I know has a positive leading coefficient, and this one has a negative leading coefficient. I really want to zoom in and see if I can find something that has to do with the fact that it's positive. I know it has something to do with the ends going up or down because we saw that on the last slide. So I'm going to look here and say, okay, well, the positive is over here on the right-hand side. Also down here, the negative one is also over here on the right-hand side. So what that means is that when your leading coefficient is positive, your right side goes up. And when your leading coefficient is negative, your your right side goes down. So our negative really tells us what's going on the left-hand side of our graph. Okay, so that was kind of just exploring all of it. On the next slide, I actually have you can see a graphic organizer that's going to put all that information together for us. I'm going to try and color code it as I go. So odds, we just said they go opposite of each other. Evens, we said go together. We said if the leading coefficient was positive, that means the right-hand side is going to go up. And we said if the leading coefficient is negative, that means the right-hand side is going to go down. So where it says in behavior, I'm going to write that in formal notation. And I'm going to start by saying what we know by positive and negative. So the right just means as x goes to infinity. Left means as x, I'm going to put that in a different color. So just remember that's really the notation that we're talking about here. So because these both have a negative leading coefficient, I can go ahead and say, okay, as x goes to infinity, y goes to negative infinity. As x goes to infinity, y goes to negative infinity. And that's just because I know that they have a negative leading coefficient, so the right-hand side has to go down. Over here, I can do a similar thing because it has a positive leading coefficient. I know the right-hand side has to go up. So the coefficient told me what the right-hand side was. Whether it's even or odd tells me what the left-hand side is. So for my odds, I know that they're doing the opposite thing. So here, my left-hand side is going to go down. That's because my right-hand side went up, my left-hand side goes down. Vice versa over here. Because my right-hand side went down, my left-hand side goes up. So we can see that relationship. Because it's opposite, the left-hand side is doing the opposite of the right-hand side. I am so sorry, I just noticed I missed a negative in here. That should make a little bit more sense. I can also talk about the end behavior of my evens then. We know that evens go together. So here I'm going to say y is still going to infinity, y is still going to negative infinity, and then I'm just going to clarify that I'm talking about the left-hand side. So we can see that they're going to go together. It's the same exact thing. And then just to give you a quick little sketch, these are both examples of evens. We know that the maximum amount of turning points, how many zeros, all of that good stuff has to do with that degree as well. These are just talking about the ends. I'm going to give you a sketch here. No. So once again, just looking at that relationship, the positive leading coefficient meant that my right-hand one was up. Negative leading coefficient meant that my right-hand one was down. Because they're odds, this one's down, this one's up, this one's up, this one's down. Because they're evens, they went the same. We could then do an example of that. I'm going to talk about example 2 and example 4. So the first thing I'm going to do is find your degree and leading coefficient. So here my degree is 3. My leading coefficient is negative 4. So I know I have a negative odd. If I start by writing this out, negative odd, I always like to start with the right-hand side because I know that if it's negative, then my right-hand side is going down. And then because it's odd, it means that my left-hand side's doing the opposite. And so you should see a negative odd, negative odd. This is a negative odd. It should match as x goes to negative infinity, y goes to infinity. As x goes to infinity, y goes to negative infinity. We'll do one last one here. So here we're going to look at this term. My degree is equal to 2. My leading coefficient is equal to 2, so that means I have a positive even. So once again, I'm going to start with the right-hand side. Because it is a positive, I know that my y is going up. Because it's even, I know my left-hand side is doing the same thing. All right. So this is where I'm going to end part 2. This is going over everything that you need to know that deals with really the degree. You can see we talked a lot about the degree. So we talked about end behavior. We have all this end behavior stuff, as well as we talked about this idea of what the degree can tell us. So there's a lot of information that we learned about the degree here. The rest of the lesson, so the multiplicity, the intercepts, and the graphing will be done in part 3.